Another geometric problem we might attempt to solve using integrals is finding the arc length of a graph of a function. So if we have, some graph of a function like this, y equals f of x, we might ask, if you started at a and you end x equals a and you ended at x equals b, if you take this portion of the graph, this red portion here, that has a certain length. If you imagine that this is a string and you grab the ends and you pulled it straight, that would be a certain length of string. So we could ask how much length is there? What is this arc length between these 2 points following the graph? Well, as with so many problems, this gets a lot easier if we break it down into very small pieces. Right? Looking at the whole extent of the problem, it's sort of hard to know how to start if you take it all at once. But let's focus just on one little piece of the problem. So, right, we can think of all of this arc length from A to B as being made up of a bunch of little pieces. Basically one little piece at every point. And what we could do is try to figure out how long each little piece is, and then add all of the pieces together. Now, of course, since there's one little piece at every x value between a and b, there's infinitely many of those. So that means there are infinitely many little chunks of arc length. And so to add them all together, we'll have to add up infinitely many, infinitely small chunks of arc length. And that sounds like it's going to be an integral. So the traditional variable name for arc length is s for some reason. I don't know why it's not L for length or A for arc length, but it is what it is, S. And so one of these little chunks of arc length, it's an infinitely small little piece of arc length. And remember, the notation we use to refer to an infinitely small piece of something is d of that thing. So each of these little pieces will be called ds. And so if we can find some nice way to express ds, then the total arc length will just be the integral from x equals a to x equals b of ds. Now the problem that we will need to solve is this ds, right? Normally, since this integral is with respect to x, we would expect the integrand to have dx in it. So what we're going to have to do is come up with some way of writing some function of x in here, so something with x, times dx. So what we need to do is figure out how can we express that little chunk of arc length as a function of x, right? Probably times the differential dx. So that's going to be our first job. Once we have that done, then we'll just be able to integrate this from a to b, and we'll have an arc length.